Welcome back to Pat Melody Vlog. I'm Pat Melody, and this is a vlog. I know it's been too long since the last one, and I'm making excuses again, but this time the excuses are different. So here's how this goes. I am subscribed to a lot of people on YouTube, as I've told you before, and one of them is a lady called Physics Girl, and she's a physicist, and she's a girl, and she's really cool, and she's also the winner of the Flame Challenge, which is something that Alan Alda started, and is this challenge to scientists to explain a given scientific concept in a way that like an 11-year-old could understand. This year she won in the video category for a video that she recently uploaded called What is Color? And that was like a couple weeks ago, and that was great. But then like last week, I noticed that she posted like this little rant on Twitter. She writes, "Can anyone tell me why I am tutoring a high school student on quarks and leptons? And why are they doing practice problems to memorize this stuff? Shouldn't these students be spending time on problems that make them think critically and learn how to problem solve? I successfully received a physics degree and don't even remember what a lepton is." And so I tweeted back, I was like, "Hey, physics girl, a photon is a boson and an electron is a lepton. Don't make me make a video." And she favorited the tweet. And I was like, okay, I'm gonna do it. I'm gonna make this video that like easily explains like all the different subatomic particles in the standard model of quantum physics, and it's gonna be like real easy. No one will ever watch that video and never be able to forget again what all that stuff means. So it'll be easy. And so I was like, okay, so let's see, okay. Okay, now I just have to start with I could probably just okay, the approach that I need to take. I spent like another entire week just sort of like researching it and thinking about it, and finally come to the conclusion that like, no, I can't actually do that in one video. And then I spent like a second week asking myself like, well, should I try to like do a series of videos on this, or should I just forget about that and not just like, cause finally today I just decided, you know what, it's been too long since I made a video, I'm gonna go ahead and do this. I'm gonna do this like series about particle physics. Maybe I won't do them all in a row, but it's gonna be a thing, and so I'm just gonna start at the beginning, and that's where, now that we're already like 10 minutes into my video. The four forces. Class is now in session. Have a seat. Alright, the first thing you need to know is that our universe is, at its most basic level, a thing that can be described by talking about four forces. Or arguably 5 if you include the Higgs field, but I think a lot of physicists would get really mad if I tried to frame that as a force right now, but I think in the end they probably will consider them. We're not going to talk about it. In diminishing order of their importance, they are referred to as electromagnetism, gravity, the strong force, and the weak force. So let's start with the most pervasive and most influential force in all the universe, electromagnetism. Electromagnetism is responsible for way more than most people realize about the stuff happening in the world. And so some of you know like, oh, that's electricity, and I know what magnetism is, and some people also know that electricity and magnetism are two like sides of the same force, electromagnetism. And then some people even know that like electromagnetism is light, like light, visible light is electromagnetism. And some of you even know that invisible light, such as radio waves, are also electromagnetism. So right there, you've got electricity that powers your house, you've got magnetism that does lots of useful stuff, you've got light, you've got radio waves. All those things are the same force, and this thing utilizes all those facets of the force. It's electric, it's got magnets in it, it's giving off light, and of course it's receiving and sending signals by radio waves. But even if you understood that much about electromagnetism, you would still be overlooking one of the even more powerful and fundamental and critical facets of electromagnetism, and that is that it is responsible for all chemical reactions and all chemical and elemental properties of all matter. It's responsible for the properties of all matter and the way that those materials... Why is this plastic squishy? Why do batteries give power? Why is this sticky? Why is this tape stretchy to a point? And most importantly, why does this metal spoon make a dinging sound? Electromagnetism. How can what you say be true? Well, it's true because atoms are composed of particles that have electric charge. You've got protons in the nucleus, they have a positive charge. You've got electrons orbiting in different shells, layers on the outside, which are negatively charged, and we'll get into that later. For now, suffice it to say that, even the very, qualities of different kinds of matter are, at their heart, electromagnetic in nature. So not only does your cell phone use electricity, it's also got magnets inside it, and it's also giving off visible light, and it's communicating with radio waves, and that's all electromagnetism, but also like the glassiness of the screen and the plasticiness of the case, all of that is also due to electromagnetism. This thing is like super electromagnetism, like all the way. That's the power of electromagnetism in the palm of your hand in all of its forms. That's why this is so cool, because that's how cool that force is. Now, it should be stated right off the bat that gravity is not nearly as strong a force as electromagnetism. We can demonstrate that for you this way. Here is a fairly heavy black piece of metal. If I let it go, gravity pulls it down. Now let's try it again in the presence of a really big magnet, and no, it won't drop to the floor. It's whoa, ow. Still, what gravity lacks in strength, it makes up for in its all-pervasiveness across the universe. Here on Earth, it's responsible for keeping your feet on the floor and keeping your car on the ground and making the things fall when you let go of them and spilling your coffee and dropping your toast. But it is not simply the force that keeps things on the table. The same force is responsible for keeping the moon in orbit around us and keeping us in orbit around the sun, along with all the other planets, and keeping the whole solar system in orbit around the black hole at the center of the galaxy. And doesn't even stop there, because gravity's not just responsible for keeping things on the table and keeping things in orbit. It's responsible for making, planets and suns to begin with. In doing so, it forces stars to fuse lighter elements into heavier and heavier elements until finally they explode. It may be counterintuitive, but we'll explain that later too. But still, so gravity has played a role in creating all of the heavy elements that electromagnetism gets to give its cool properties to. So they're best buds, really, gravity and electromagnetism. And gravity doesn't just hold things on the table and make planets and make stars and make heavier elements and shape the structures of galaxies and galaxy clusters, but it also bends and warps space itself. I mean, we think of space as being, kind of just nothingness, but it's not, because it's a thing. It's actually space-time, really. That's a whole other thing. But gravity is capable of warping the fabric of space-time. So kudos to you, gravity, because no other force can do that. If we didn't have the strong force, then if you get a proton here and another proton there, and they're both electromagnetically positively charged, then they will repel each other. They don't want to be together in any way. No, get away from me. But if they get close enough, the thing about the strong force, it only works over a very short distance, a very tiny distance. But if you get within that distance, it is much stronger than electromagnetism over that tiny distance. And so if you get two protons within too close, and then the strong force will be yeah, you two are staying together. There's nothing that's going to tear you guys apart. Never again. And that's actually true just for one proton, because one proton is made up of three quarks. and the strong force is responsible for keeping those quarks together too, and that's something that we're not getting into now. We're just talking about the four forces, but that's in the future. The point is, without the strong force, we wouldn't be able to have atoms at all, because it wouldn't be able to have nuclei that would stay together, and as it happens, the number of protons in the nucleus of an atom is what defines what element it is. It defines its atomic weight and how many electrons and electron shells it can have, which in turn define the properties that it will have. And I can be honest with you, I don't really understand the weak force that well. It's sort of a little beyond my ken. But I do know that it is responsible for nuclear radiation, like radioactivity, like the decay of, uranium, and as it slowly decays and loses alpha particles and turns into lead. That is, the weak force is at play there, and you're like, well, yeah, but we don't need that. Radiation's bad. The weak force is bad. But it's actually not, because it plays a big role in the fusion happening in the sun, the fact that the sun can shine, and it also, radiation deep within the core of the Earth here on Earth is responsible for a large amount of the heat that's down there beneath the crust, and if we didn't have that heat, we wouldn't have, a magnetic field, and we wouldn't have volcanoes creating new land masses, and you're like, oh, volcanoes are bad too, but they're also good because they recycle the rocks, and it's that's okay. Weak force. That's all I gotta tell you really about the weak force. But I'll do more reading on it. At any rate, those are your four forces: electromagnetism, gravity, strong force, and weak force. Next installment, we will discuss how the particles known to physics are defined by the way that they either interact with or do not interact with these four forces. Class dismissed. What to do on a plane with no Wi-Fi? Prove the law of cosines. Oh my god, look at all that math.